Alright, continuing on with section 6.1. This is going to be 6.1, part 1. Using integration by parts. Alright, so example number 3. We've got the integral of 6x times cosine x dx. So we need to figure out what we want to set equal to u, which in this case we've got the algebraic function with the trig function, so we'll go with the algebraic. And then, so u is equal to 6x, and then dv has to equal everything else, so cosine x dx. Now we need to integrate that, so the integral of cosine is going to equal sine x, and then the derivative of u is going to equal 6 dx. And now using our formula, we've got the integral of v du. No. Back. The integral of u dv is equal to uv minus the integral of v du. Okay, and so that's our formula we're using. So we've already discovered what u and dv were. So now u is 6x, v is sine x, minus the integral of v, which is sine x, times du, which is 6 dx. And so we've got 6x times sine of x minus 6 times the integral of sine of x dx. And so that's going to be negative cosine. So we'll end up with 6 sine of x plus 6 cosine of x, and then plus c. So example number 3. 6x sine x, 6, yep. Okay, example number 4, we have an integral that we can evaluate, but be really careful with using your calculator. Mind if you use your calculator to check, but I am going to be looking for all of your work on your test for this. So make sure you know how to do every single step here. Okay, so we've got to find a u. Now this case, remember our acronym that we can use here. We have an algebraic function, but we also have a logarithmic function. So if we've got a logarithm in there, we're always going to use that logarithm first. So u is going to equal the natural log of 2t. And so du is going to equal 2 over 2t, which then we'll just simplify to 1 over t dt. And then our dv is going to equal everything else. So dv is going to equal 2 squared, t squared dt. And now we want to integrate dv to find our v. So v is going to equal, let's add 1/3 t cubed. And now we can follow our formula. So our formula is uv minus the integral of v du. So the natural log of 2t times 1/3, I'm going to write that out here in front, 1/3 t cubed minus the integral of v du. So v is 1/3 t cubed times du, which is, that simplified that 2 out. So 1 over t dt. So we've got 1/3 t cubed natural log of 2t minus, we can pull out that 1/3 times the integral of t, oh, cute. Nice. T squared dt. And now we just need to integrate that, so we'll add 1, divide by that number, so we'll get 1/9 out here in front, and t cubed, and then plus a c, and then all this out here in front stays the same. And then that will be our answer. Oh wait, no, we got to end where this one is evaluating. Sorry, so we don't need to put in the c, because we're going to evaluate instead. Ooh, that's gone. That's close. and then we're evaluating from 6 to 3. So I'm okay with using calculator from here. Well, if you get that equation, then I'm happy. You can go ahead and plug that equation in and use your table from there, and I get the answer of 141.7872. Okay, and moving on to example number 5, we are going to evaluate this one again. Hopefully I don't forget that. And we've got a logarithmic function, and down here underneath we've got a algebraic function. So we're going to say that u is equal to the natural log of r, and that dv is equal to r to the negative 3 dr. So du is going to be 1 over r dr. And then the integral of this one over here, we're going to add 1, divide by that number. So negative 1/2 r to the negative 2. And now we're ready for our equation. So uv, so the natural log of r times negative 1/2 r to the negative 2. So that's uv minus the integral of v du, so negative 1/2 r to the negative 2, times du, which is 1 over r dr. Okay, so lots of fixing we can do on this one. So I'm going to put negative 1 over 2r squared natural log of r here, minus, well, it's going to be a plus actually, so plus 1/2, and then times the integral of 1 over r cubed dr, and then we're ready to go ahead and integrate there. So 1 over 2r squared natural log of r. Integrate this, we're going to get negative 3 plus 1, negative 2, divide by that number, so it's going to be a negative 1 over 4. Skipping a lot of steps there, hope that's okay. And then that is 1 over r squared. And then plus, oh no, not plus c, we've got to, yes I do. We've got to evaluate this. So once we get to this point, evaluate from 1 to 3. And plug the 3 in and the 1. You can use your calculator from there. And that is going to be our answer for example number 5. Alright, example number 6 is a little bit of a tedious problem. I'm not really going to work through the whole thing. Just the same as everything else that we've done. Make sure that you choose in your u to be the natural log of r, your v to equal r, let's just say r to the 3/2 dr. Integrate here, take the derivative of this, plug it into your equation, and then simplify it down as much as you can. No numbers here, so we're not finding an actual number. Just simplifying, remember to add c. And this is our last example. So use integration by parts to evaluate 3s e to the negative 5s. So we've got an exponential function here. So our acronym, exponential equations are going to be the very last ones. So definitely not going to be choosing that one for u. And then we also have 3s, which is algebraic. So u is going to be 3s, and then dv is going to be everything else. So e to the negative 5s ds. Now find the integral of that. So v, remember, if you have to, go back through and review that u substitution. But it's going to be negative 1/5, kind of think of it as the chain rule, e to the negative 5s. And then du is going to equal 3ds. And then go ahead and put it all back into your formula and evaluate from negative 0.9 to negative 0.1. And you can do that evaluation on your calculator, but make sure you get clear through to your equations on these, because I will be checking for that on your tests and your quizzes. And so that's all I've got for 6.1.